Cool, thanks. So I've obviously done a bunch of mobile development before, but recently moved into this AI machine learning world, and it's really exciting. And what I want to present tonight is kind of how those two things have come together for me with a piece of work I've just been looking at. So we've had a client approach us recently talking to us about traffic surveys and how they're time consuming and manual. You've probably seen those rubber pneumatic strips across the ground to count cars, and they're costly. A lot of these surveys, they actually just film a road for 24 hours and they send it off somewhere, and someone will actually manually write down how many cars went through. They'll review it later. And this client asked me, can AI be used to help actually the traffic surveys and analysis perhaps in real time? And it got me really thinking, you know, can we do that? And I started to explore that. So what I want to present tonight is what I found and the journey kind of I went on around how could I actually get these, a small device up on maybe a pole to do some traffic surveys, traffic counting. And I guess for me, moving to this AI world, is this achievable for mere mortals like us? So I had a bit of a look around on the internet. Hopefully this will start soon, if I'm lucky. There's a bunch of people doing traffic analysis already with this sort of technology, and I wanted to see how good or bad it was. This is pretty damn good. So this is an intersection. They've actually got a drone hovering over the top. So add blockchain and they've got all of the buzzwords in there. Yeah. So this is monitoring traffic with a hovering drone. It's actually tethered, so it can actually real time stay up there for quite a long time and transmit that sort of stuff back. What I don't quite see at the moment, or you can see it counting the cars as it goes across here, which is really nice. So that's the sort of thing I wanted to do, but I want to do that as a mere mortal and in real time with commodity hardware. So maybe mobile devices, maybe other devices, but probably not a $3,000 drone. So is this realistic to produce on a small device? So this is kind of the journey I've been on for the last couple of months. So I knew there was a bunch of computer vision techniques and cute cats and dogs that we can try them on. We've all seen a lot of AI techniques around image classification. So what's in that image? It's a cat. Classification localization is it's a cat and it's right here. What we saw in that last video was object detection, being able to say, I see multiple images here and it's a cat, a dog and a duck, and here's where they are. The last one around instant segmentation is probably a bit too advanced, but that's more in the realm of automated driving. So I wanted to focus in on object detection. Can I do that sort of thing with AI? Now I'm not sure how familiar people are with machine learning and AI. Let me give you a quick kind of conceptual overview of what it is. So basically it's taking a bunch of data that you've got. Maybe you've got a bunch of images and each image has got a box around it with all of the objects in there, and each box has a label against it. So that's the historical data. What we do is we split that data between test sets and a training set. And we take a training set, so this is maybe 80% of our data, and we send that to our model to actually train it, to have the model say, learn what is in those images. But remember we had some test data off at the side there, the test set. So this is data that our model's never seen, but this is really useful for us to be able to evaluate how our model is going to perform with images that it's never seen before or data that it's never seen before. So we train it, we evaluate it with our test set, and then what I wanted to look at is how we can predict data. So this would be video images coming in from an intersection, and we'd be able to predict what we see in that picture with labels and classes. That's kind of the conceptual machine learning process. It gets deep very quickly. So a lot of this is built on neural networks, which we've got here over on the side, and when you decompose them down, these little dots here are actually quite simple, and you might have done some of this stuff at in high school mathematics with linear regression or logistic regression. Matching a straight line to a bunch of data on a graph is essentially what each one of these dots does at some level. When you scale this up into these sort of models here, this is the Inception version 3 model from Google, using different techniques around how you actually combine this data together or how you compose these units together, suddenly they can do some really, really magical things. We won't get into the maths of that tonight, but happy to later if someone else wants to have a chat. So the Inception model is about image classification, but I'm interested in object detection models. So this world is fantastic, these models. All of these come not only as research papers, but actually as kind of like an open sourced composable libraries that you bring in now. The recent TensorFlow Dev Summit, they actually launched TensorFlow Hub, which looks a bit like a GitHub or a way you can actually bring in the kind of libraries or pieces of models into your code as well and make it your own. And what I found is this world of these models with these strange names actually can be reused. This graph here is a graph of kind of the zoo, as they call it, of object detection models that are available to us today that I could use on maybe that traffic survey. And it graphs something called an inference time. So inference, just think of it as prediction, how fast it can predict something. So we obviously want it as fast as we can. And this one here is how accurate we can actually do the prediction. So this graph is obviously from the YOLO version 3 models. YOLO stands for you only look once. So that's a really fast way of doing this. And these guys are pretty cheeky in how they do it. So this was the standard graph that people were tracking. They brought out a version 3 which is super fast. They didn't even bother to readjust the axes. They just put themselves up there and went pretty fast and moved on. Let me show you a bit of what the YOLO model can do. This is actually, I've chosen the YOLO 2 model tonight just because it's a bit more impressive. It's all very branded and everything as well. So I don't know if I can put music with it as well. So this is obviously from James Bond. There's a lot of people in the scene. You can see it picking up tyres and everything like that. Very, very quick. Some things it gets wrong. I think later on it picks up a train in the middle of nowhere, but you see it picked up a cell phone there as well. But mostly it's correct. Mostly it's working very, very fast at around 50 to 30 milliseconds. That it can actually make a prediction about that frame as it comes in, what objects it sees and where they are. Just see if I can get wait till we get to the bit with the train. Oh yeah, so it thinks there's a train coming up here somewhere. There it is. I think that's a train. So it doesn't get 100% right. That's certainly quite interesting. Now, I don't want to detect tyres. I don't want to detect some of those things, but some of the things I do. So I actually wanted in my traffic surveys to detect types of maybe trucks or different types of cars, SUV versus a smaller car. So what I then moved into that is, okay, I can use this YOLO model or any of the other ones in that graph. How can I actually train it on my objects? Well, we have this really cool technique called transfer learning. Transfer learning is a really awesome way for us to take a pre-trained network. So what we were looking at there with that YOLO model is it's been a network that's been trained on a bunch of images like tyre and car and person, and actually been trained for this data here. But then I can come along and say, but I'm interested in trucks, B-double trucks, and I'm interested in these other object types. And you can actually transfer the learning that's done on here to my network over here. And the reason I want to do that is because this step here, training from random to first neural network, takes a very long time with a lot of hardware. And I don't want to do that again. But what I want to do is take a short amount of time, this fine tuning. And this process here can take an hour or so, this transfer learning step. And we'll have a look at some later on. So conceptually that's great, but I actually need some help to do that. And thankfully, I've got a couple of friends here with TensorFlow and Google Cloud ML. So TensorFlow, at its core, is a really simple kind of graph mathematics framework. It allows you to multiply matrices at scale, essentially what it is. But you build up from that with layers, and suddenly it's doing some amazing neural networks. And recently what they've given us is this object detection API. So it allows me to build on TensorFlow. It's all open source. It allows me to construct a model, train a model, either locally on my laptop here or in the cloud. And all the configurations for all those different models in the graph are actually provided with TensorFlow itself. And that's been really, really powerful. Coupled with that, the ability to use Google Cloud Platform as well, so Cloud ML. So I actually don't have a good graphics card or something that's really good at training neural networks on these devices here. So I need, so I thought about buying a graphics card because I like buying stuff like that. But instead I like spending money with Google Cloud Platform as well for a short period of time, and I'll show you how we can use that as well. So, neural networks are embarrassingly parallel is how we talk about this stuff. And that's really handy for us, because not only can we train our neural networks on GPUs in doing all of these parallel pieces of work, but we can actually scale out the machines with those GPUs as well in Google Cloud. And it's not only embarrassing parallel, it's embarrassingly easy to do. So this little bit of configuration over the side here, this is the Google Cloud ML configuration. And what I've got there is I've said we have one master node, the one that kind of controls it all, hopefully it doesn't go down. But the most important thing is these work accounts. I've actually got 5 there. And they're using standard GPUs. So I can just say, oh, just give me standard GPUs. Or you can say, give me really big ones, or give me super big ones, if Google trusts me enough. And I can get access to that for a very short period of time. And I can configure 3 or 5 or as many as I like, or 1, just with the configuration file. And what that does is it takes my training time down for me training my model on trucks or different types of things, down from what might take weeks, days, 8 hours, down to 1 hour or 30 minutes or so, which is remarkable. The other really clever thing about this as well is that there's no code change required here either. So if I want to train my model on my laptop here, but then decide, oh, it's too slow, which is actually what happened, I want to train it on here, I can do that by changing the configuration, no change in the code at all, which is really, really powerful. So, I know we haven't got devices yet, but let me just show you some of where I've got to with training a model. Now I can't show you the actual model I've trained, because it's still with the client. But what I can show you is some dogs and cats, which is probably going to be alright, I guess. Let's have a look. Not actual dogs and cats for anyone who's getting excited. Here it is. Oh, let's go backwards. Right, this is a boring graph, but it's quite important, but I'll get to something more interesting in a minute. This is me training my model over the last 8 hours. I kicked it off. I just did one worker. It cost me $20 in Google credits to train my model. Maybe I should buy a graphics card. It's just so you understand. And I've got 2 points here. This red line here is how well my model is trained on my training data. Remember, that's that data I just keep sending it and saying, learn what a dog looks like, learn what a dog looks like. I keep telling it to do that. And it learns very, very quickly. But it's actually quite accurate and gets a bit noisy down the bottom here. This blue one here is all of the data that I haven't showed it before. This is my training data that I said, I kept it away from the training model, but every so often I actually swing past and go, how well am I going on this data? And it gets more and more and more accurate. And basically what you want to see is this blue line coming down to this red line. It's a good indication that your model is becoming better. It's called generalizing. It's going to perform better in the wild, not just on its training data that it's seeing there. So, boring graph out of the way. Let's, oh, nope, I'm on this one. Let's have a look at some images. Even better than that, what we can actually do is see how well or how badly it's predicting some of these objects here. And even better than that, over time. So when my model first started, it didn't know what the hell that was. It said there was nothing in that picture. And then after 2,000 steps, it said that's 50% chance of a German short-haired. And then, later on, it starts thinking it's American Bulldog. No, it's the German short-haired again. I'm much more sure, 80%. I think there's 2 dogs in the picture, and so on. So, don't like cats. I don't know what that is. Does anyone? I've been testing with this for a while, and it's very sure that it's this.
Yeah.
Is that it?
Yeah.
Yes. That's good. Sometimes you need humans to help. This is a pug. I'm pretty sure it's a pug. How sure am I? I don't know. Let's have a look. Let's see if I can change this. 90% sure, 73% sure. I was 95% sure at that stage. This is really interesting, right? As the training goes, sometimes it's good and sometimes it gets worse. So sometimes there's a technique called stop early, which is a bit of a cop-out, but it's basically like, oh, it's good enough, stop before everything else breaks. It's not the best. I have a Cocker Spaniel. That's not a Cocker Spaniel. I don't know if it's a Wheaten Terrier though. But these are great visualizations over time, and they're really exciting to watch. So I've been training with a couple of sets of data, obviously this, so I can show you tonight. But it's a really good visualization tool. Right, let's get back to devices. So, kind of felt pretty confident that I could actually train a model at that stage. But then I'm like, right, I take the model and I put it on one of these devices, or which device, and what are going to be all the problems with it? And then I started to get worried because I know that they take lots of power, and these models are huge. Some of them are 200 meg on disk, and depending on how I wanted to do it, if I wanted to send all the video from the traffic survey back to a server to do all the AI on, well, the bandwidth and that'd be huge. So I actually wanted to do it locally on a device. So I had a bit of a look at TensorFlow Lite. TensorFlow Lite's pretty new. I know that not just from the date, but because it's pretty rough around the edges still. But it's the right path. They've previously gone with TensorFlow Mobile, which was basically just a clever way of compiling it so it worked on mobiles. This is thinking about mobile from day one. This is thinking about taking a model, converting it into this Lite format that's better suited on mobile, and actually making great interfaces for it that can be optimized across both platforms. They've done a lot of really smart things in this that they're improving on each day. I probably can't go into a lot of it tonight. Happy to talk to people later about it. But this is probably the place to start. The really exciting thing for me is I'm seeing them start to build on the Android Neural Networks API, which I can talk about as well. So when I saw this as well, I'm like, oh, maybe I'll build my app on the Android Neural Networks API. That's not how Android wants you to do this, or Google wants you to do this. They want you to build on your machine learning framework that you're most comfortable with. This Neural Networks API is actually here just to abstract away the mess that's down here around the hardware, around the different vendor drivers, around falling back to the CPU to do a lot of the AI work if it becomes too complicated. But really provide an abstract to that, so then you could use TensorFlow or Caffe or MXNet or any of those sort of things on it. So this is, I wouldn't recommend starting with this unless you want to build your own custom version of TensorFlow, but really to step up a bit higher. Having said that, I was interested in what's going on down here, particularly when TensorFlow Lite was so new. So I went a step lower as well. So the Snapdragon device that's in my phone has a neural processing engine. And they didn't originally. They had a GPU, and a CPU of course, and they had a digital signal processor, basically for the camera. So when you take a picture, it can do that HDR and all that sort of stuff. But they kind of realized that that's actually really good for neural networks as well, because you can multiply and add matrices really, really fast. So let's call it the neural processing engine, which is fine. So I had a look at that as well. Again, it's kind of odd. You can build things for it, but again, I think I'd move up the stack and build things on TensorFlow Lite a bit more. Interesting to note, the Pixel 1 has the DSP disabled for use as an app developer. I think it's because it's a bit slow anyway. They don't want you kind of carving out a bit of time on that DSP. The Pixel 2 apparently does work. I haven't tried it yet. I'd love to see how much faster it is, and we'll have a look at a demo in a minute. Anyway, mobile aside, I started to look at some of these devices, particularly one of these, which you're going to pick me up in the US, right?
Oh yeah.
They sell these at Target for $90 now. This is actually a screenshot of my pre-order. It's $250. This is the AWS Deep Lens. So I pre-purchased that in November, and it's going to be shipped in June. It's not great. I probably won't buy it again. So not being able to do that, not much happening on Android yet, but it's very much in play. I had a look at this thing, and I tore it open in a picture. And if you zoom in a bit, you see it's just a Raspberry Pi Zero, which is awesome. That's just exactly the sort of thing I want. And then I saw this little board here. This is the AI board. How do I get one of these? Of course, you can't get them here. But if you zoom in even closer, what's on that board is one of these things. This is the Movidius Myriad Pro X chip. They call it a vision processing unit, which is a terrible name, but these things are really cool. And you can buy them today, which is great. This is what I wanted. I wanted immediate satisfaction. So I went and bought one of these Movidius chips here in a USB stick. So it's this chip here inside a USB stick, and it's really for prototyping. It's really for exactly what I wanted to do. Can I do AI with object detection fast on a really cheap device? So I grabbed one of these devices and chucked it in one of these laptops, and let's see what happened. So the reason I'm switching, obviously tonight as well, is that turns out AI is sometimes a little bit more friendly on Linux devices than Mac, particularly this sort of device, and it really kind of helped me emulate a Raspberry Pi type environment. Which way am I going? Has anyone seen the screen? Oh, there we go. Right. So this is object detection with this neural stick here. This is a... Hey! What's wrong with Luke? Not quite a person. What I was actually thinking of making is something that could count how many people are in the crowd. Just pan around and... But generally it's pretty good. So that's totally running on that USB stick. It's there's no CPU or anything going on there. If you have a look at the CPU on the device, it's actually using hardly any at all. And the really cool thing is that little device here is only using 1 watt of power, which is less than the Raspberry Pi itself, which is just a remarkable achievement.
It's just for persons? If you decide.
So this is just trained on a person's model, but if I use that transfer learning approach before, I can put other models on this as well. Which I'll wrap up. I think I should wrap up. It's fun though. All right. So what I found is this kind of landscape's pretty much evolving under my feet. A lot of the things I was finding with Git, I was finding issues that were posted like 20 days ago, 7 days ago, 2 days ago, 2 hours ago, and you're like, oh, this is really painful. So it's actually shifting as you're trying to look at it, and which is exciting because I want to actually learn more about it, but it just means that you need to be prepared. That this TensorFlow Lite's moving, this is moving. Even this object detection API, the reason I couldn't use 5 workers and get it done in an hour is because it's broken at the moment. So I have to use 1 worker and train it for 8 hours. Even the Movidius Snapdragon support, hardware vendors are not so good at that sort of stuff. And Core ML support for TensorFlow Lite kind of came in at the end. So I think it is possible. I think the traffic survey stuff that I looked at is something that's feasible and something that mere mortals can do. I'm pretty excited about I/O. I hope there's some more AI machine learning stuff there. But I'll finish it there, and maybe if there's any questions.